You guys dealt a lot with angles in your geometry class, and in geometry, angles were often a part of something bigger. We were looking at angles in a triangle, angles in a polygon, maybe angles formed between two parallel lines, and a transversal, just all sorts of different situations there. Something you probably didn't see too much of, though, is talking about angles in the context of the coordinate plane. So what I mean by that is we're taking the basic concept of angles and we're applying them to a typical coordinate plane like the one you see right here. When you talk about angles in standard position, as we're going to call them, standard position means that we're going to have our vertex of our angle at the origin. So our vertex of our angle is right there, and we'll always have one side of our angle going this way. One ray is going to be along the positive x-axis. That ray is going to be called the initial side of our angle. So the side that starts out on the positive x-axis here is called the initial side. And then what's going to happen? Picture this is one side of my angle here. For the other side, I'm going to have my ray, and I'm going to basically spin it like this, going along, anchored to the origin there. So it's going to spin in circles as I go along. I can spin it this way, I can spin it this way, but the other side is going to be just somewhere else. Let's say it happened to be out like this. So my angle would be an obtuse angle formed by the positive x-axis here, and this blue line you see drawn in. This second guy right here is called the terminal side of the angle. So we have the initial side and the terminal side, and we have our vertex at the origin. And what we're going to do is basically investigate different things that happen as we spin our angle in different directions. One more note on this page before I show you some introductory angles here. The default direction that we spin is going to be counterclockwise. So when you spin angles, if I talk about a 90-degree angle, what that means is I'm spinning at 90 degrees counterclockwise, which is going in a circle like this. So when you spin the angles, we go this direction. It's almost like we're following the quadrants through. Here's quadrant 1, quadrant 2, quadrant 3, quadrant 4. You follow the quadrants as you spin them around. If we're to go in the other direction, what that would mean is that we have a negative angle, which can and will happen in these problems. So for this first video here, I'm just going to talk about some key angles that you should be aware of. When you kind of just see them, you should know them right off the bat. The first of which is just a standard 90-degree angle. We have our initial side right there, and our terminal side would be right here. And what we'll typically do, because if you just see this, you have no way of knowing if they spun it just to here, if they spun it in a full circle and then to here, if they went backwards this way to here. We'll have some sort of an arrow right here showing which way we spun it. And then I would write right there that it's 90 degrees. Just like in geometry, if you were to go a straight line 180, straight line, that's 180 degrees. So if you spin from here to here, that would be a 180-degree angle. And if you were to spin then, still starting right here, you spin it past the 90, past the 180, all the way down to here, you would hit 270. So if you go all the way from there to there, that would be a 270-degree angle. So you can kind of stack together the 90s and add them up to get your total so far. If you go in a complete circle, therefore, so you have the first side of your angle here, and you go all the way around and land back on that same angle, that would be shown like this, and that's going to be a 360-degree angle. So if you go in a full circle, that's 360. It's very helpful to know that if 90 degrees is a full quadrant right here, if you go exactly halfway like that, that's what a 45-degree angle would look like. And finally, all of these same angles here can be done in the negative direction as well, or in the other direction as well. So far we've been spinning this way, and we've had positive angles right here. It is actually possible to have negative angles in the coordinate plane, and that happens when you spin it this way. So say I spun my angle to right here, this would actually be a negative 90-degree angle. We're spinning in the opposite direction here. So it looks like a 270-degree angle if you were to look, I mean, same as this picture over here. But depending on which way we spin it, we can have negative angles as well. So that's something that couldn't happen in geometry, but in the coordinate plane, you totally can.